Well, it's next week, and I said I'd do an update every week, and here is what I'm going to do. So this is growing, uh, but it still needs to grow a lot more. Okay, let's just go through it, just to go through what I've got so far. C-reactive protein doesn't seem to be a trend, except for the fact that between ages of 20 and 30, it's like it wouldn't be above 0.6 or something like that. And then here for the rest of the life, it's like, all over the place. And then it's kind of goes down again. I'm going to go based off of these suboptimal data sets for now. And as I get more and more data sets, then hopefully my understanding of all this stuff will be improved. IL-6 looks like there's a trend in the terms of the maximum IL-6 milligrams per deciliter. But again, if you had an IL-6 measurement of like 0.8, you could be anywhere from 20 to 70 years old, right? So it's anyway, okay. TNF alpha, not really much of a trend. Oh yeah, so okay, so IL-6 looks like there's a lifetime trend going on here. C-reactive protein, probably not. TNF alpha, probably not. Mean telomere length, which is actually a bad way of measuring, as I have learned. You should do lowest telomere length, but I got to take what I can get in terms of these graphs. It looks like there is a lifetime trend. Mean lymphocyte telomere length looks like there's a lifetime trend of data. Testosterone, very surprising. This data set shows that there's actually not, I always thought that testosterone lowered as you got older, but apparently this data set shows that it stays pretty constant. And then there's some outliers with low testosterone that probably pulls the average down. But I mean, for the most part, it doesn't seem to change. And if I'm not sure if this data, it said it's like a normalized data set. So this is 1 is here to 0 to 2 or something like that. So the units are arbitrary, or maybe not, nanomolars per liter, nanomoles per liter. Yeah, but this is surprising. There's probably should be some follow-up to look at that later at some point. Total energy expenditure is kind of like a curve. And actually, this is like the curve of life. It really looks like it, like, how the arc of life occurs, like, and then goes back down. Okay. PROS1, this is some kind of, I forget, this was, I forget what this was. I should stop using acronyms. But this, it doesn't seem to show much of a trend. That line seems to be a big stretch. A1C doesn't seem to show an overall trend, although this thing, the base kind of goes up like this over here. ApoA4, apolipoprotein, doesn't seem to show much of a trend. CD3, no. CD4, no. CD8, not really. I mean, they put this trend line here, but it's like, come on, like, look at this thing. It looks like I shot the graph with a shotgun multiple times. NKT doesn't seem to be much of a trend. Hematocrit stays pretty flat. Hemoglobin stays pretty flat. Platelets stay pretty flat, but all of these ones, it's kind of interesting. They have this section in the beginning with what I think is just more dense data. That's why it looks different. I can't be sure if it's just a denser data cluster or if there's actually like, there's a lot of these these pieces of information where it's like between the ages of like, 0 to 20 years old, there's a different sort of curve than the rest of it. And that kind of makes sense. Well, this is 20 to 30. Okay, well, whatever. It seems like there's an early stage of life where there's like a bunch of like a different sort of trend line, and then the rest, some of these, maybe what the curve looks like is like there's between birth and then age of reproduction, there's one pattern, and then after age of reproduction, it just sort of flattens out or something like that. That's a possibility. Platelets, MCV, also kind of flat. Trend seems to trend upwards a little bit, but nothing too dramatic. White blood cells seems to stay pretty constant throughout your life. IGF-1 has a peak. Other than that, it stays pretty constant. If you had an IGF-1 of 200 on this graph, you would not be able to tell how old you are at all. There's no way to, but if you had it at 500, you must be between the ages of 10 and 20, probably. So, yeah. What were these? Oh, this was for females and males. I said they had separate graphs, so I separated them out. This one has got females and males, but they're all in the same graph. Anyway, so far the only really interesting one has been testosterone, which, you know, to be honest, is worth this whole effort by itself to understand that. Because then we can, if this turns out to be true, we can ignore all those testosterone supplements and all that other bullshit, you know. Okay. Yeah. Now time for a little bit of biophilosophy. Just a smidge. Bacteria are defined as organisms that typically cannot affect their environment, or just in very limited ways. What they typically do is they divide, they consume, and then they either produce so much pollution that they die, or that they move on. You know, they move to greener pastures, so to speak. Yeah, I need to make sure to not be a bacteria. It's a loosely defined metaphor for like how certain people will just consume resources from around them without being able to change their environment. So the problem is that on a life scale, if the value that you're trying to create is extremely difficult, then functionally there's no difference between there's no difference between someone who fails to produce value and someone who never intended to produce value in the first place. From I guess the universe's perspective, those two people are exactly the same, right? Judge people by their actions, not by their words. So this is going to be, I mean, this field is going to be difficult. There's a lot of bullshit and bullshitters in this field, but we're going to get there. I think we're going to get there. Well, I have no idea if we're going to get there, but this is what I'm going to do. So, you know, whether or not we get there, the commitment has been made. All right.